Question 5 is about the photoelectric effect. Now part A is asking you to say what is meant by the photoelectric effect. So I'm not going to tell you that on here. That's something for you to find from your notes, find from your book. Or there is a video also on the YouTube site that talks about the difference between photoelectric effect and energy levels. So have a look at that. So state what's meant by the photoelectric effect. Explain how two observations made in photoelectric experiments suggest that electromagnetic radiation behaves like a stream of particles rather than a wave. And we talked about this in class. If you're not sure, if you can't remember, it is in the book, page 30 on the book, which introduces photoelectric effect, lists some puzzling problems, things that couldn't be explained. So I suggest that's where you look to find the answer to that question. Now part B is a calculation. And if I show you how to do that calculation, I'll have done it for you. So I'm not going to do that one. What I'm going to do instead is a very similar calculation, exactly the same method, but involving different numbers. So the question tells you how much energy the photons have got as they come in and hit the plate. Then it tells you the maximum energy of electrons emitted from the surface. Now if we actually write down the full equation, it's probably making things more complicated than it needs to be. But let's imagine that we were in an exam, we weren't quite sure, we were looking at the data sheet, we were looking to use the formulas we're familiar with, then we'd be familiar with the formula, it's on the data sheet, HF equals phi plus EK max. Now in this equation, HF is the energy of a photon, and when you give it in that form you can calculate the energy of the photon if you're told the frequency. But in fact we don't need to calculate the energy of the photon. We're not told F, we're told the energy, so we're already told HF to begin with. So 2.1 times 10 to the minus 18 joules, that's already HF. The maximum energy of electrons emitted from the surface, well that's EK max. So if we're told what the photon energy is, and we're told what EK max is, then either by using this equation, or by bypassing the equation, just using common sense and the ideas of what the words tell us, we know that the energy of the photon is equal to the work function plus the maximum kinetic energy that the electrons have. So therefore, to find the work function, it's just the difference. So we either do it mathematically by rearranging the equation, so you take the EK max up to the other side, it becomes negative, or we just use common sense and say it's the difference between them. So the work function must be the energy of the photon minus the maximum energy that an electron has. So the work function is equal to 2.1 times 10 to the minus 18 minus 7.8 times 10 to the minus 19, 1.3 times 10 to the minus 18 joules. The last part of the question asks you to find the wavelength of the de Broglie wave associated with the emitted electrons. You've got to remember that some photons come in, it's hit the metal surface, an electron has been emitted from the surface and is moving away. And whenever particles are moving, we can sometimes think of them as being waves. In this case, we're asked to find out what's the wavelength that we could think of that electron as being, if we think of it as being a wave. So, if we look at our data sheet, the formula for de Broglie wavelength, lambda equals h over mv, where h is Planck's constant, which we can look up if we don't remember it. M's the mass of, in this case it's the electron, and v is the speed of the electron. And it does say that we're dealing with the electrons that are going the fastest, in other words the ones that get the full share of kinetic energy. So, do we know the mass of an electron? Well, we do, because we can look it up in the data book. Do we know the speed of these electrons? And we don't. We're not told the speed, but what we do know their kinetic energy. Because the kinetic energy of these electrons was given earlier in the question. There, 7.8 times 10 to the minus 19 joules. So we have to really go back to what we know from GCSE. We know that kinetic energy is a half mv squared. And we recognise when we write that we've got m and v in there, so hopefully that's going to be useful to us to find mv. So what's the value? Kinetic energy is 7.8 times 10 to the minus 19. That's equal to a half mv squared. Now I know m, I'm trying to find v, so if we rearrange this equation, if I multiply that by 2, what do I get? I could use a calculator, I'm not going to bother. I'll get 15.6 times 10 to the minus 19 equals mv squared. And if I now divide by m, and if I look in the data sheet, I know what the value of m is, so 15.6 times 10 to the minus 19. Notice I'm not using proper standard form. Should do really, but never mind, it'll all come out in the wash. Divided by the mass of an electron, looked up on the data sheet, 9.11 times 10 to the minus 31 kilograms. That's equal to v squared. So if I work that out, then v squared is equal to that, 1.71 times 10 to the 12. And if I take the square root of that, that tells me what v is. So v is the square root of all that. So v 1.31 times 10 to the 6 meters per second. So now, go back to lambda equals h over mv. We know the value for h, 6.63 times 10 to the minus 34. The pen holds out into this question. Divided by 9.11 times 10 to the minus 31 times the value we've just calculated, 1.31 times 10 to the 6 equals 5.56 times 10 to the minus 10 meters.